Welcome to video lecture series. Kindly like, share and comment so that we can able to get the new videos. So now here I am going to discuss about the how to execute the Blink LED program on 8051 microcontroller hardware. So here we need to understand the procedure for executing a program. So here we are going to use 8051 microcontroller. It is a 8-bit controller. At a time is going to perform 8-bit operation. So I am not going to explain in detail about the architecture and all. Here the required things for this program, I'm going to explain you how we can do practically and the tool which is to be used and also the hardware how we can going to use that I will explain you in detail. See here, this diagram is for it is a 8051 microcontroller board. It consists of 8051 microcontroller that is particular from Atmel company 8089S52 microcontroller. This 40-pin microcontroller, and it is a programmer. We are going to use the programmer here. So by using the SPI interface, easily we can program from the desktop or laptop. We can transfer the program into the memory of the 8051 microcontroller. So here I connected one LED because to execute blink an LED, I connected P0.0 of the port to the positive of the LED, and its negative I'm going to connect here the ground pin. Here ground is there, here 5 volt, here 2 volt on the board it is available. So I'm going to explain you in detail about each here, each part. And this is the board. Just here I'm showing only the board. This microcontroller board. Here see 8089S52 microcontroller. And another one device, there's a programmer I'm going to use here. So easily we can download the program from the desktop or laptop through USB. That is the reason this additional device we are going to use. Otherwise, you can use directly this serial port communication. So here easily we can do through USB, easily you can download the program. Once if you generate hexa file, okay, that also will explain in detail how to generate hexa file. So this is the board, actual board. It consists 89S52 microcontroller. This Atmel company is a 40-pin and is having 4 ports: port 0, port 1, port 2, port 3. Here the pins are available for connecting the any IO devices. And also on the board we have ground pins, and this is 5 volt DC, it is available, and 12 volt DC, and there is a reset pin. Whenever you press a reset, start execution from the beginning. And you can connect the power supply from the mains so that through using adapter, here it will be converted to DC 5 volt. You can have 9 volt to 18 volt, either AC or DC, both it will be acceptable. Through adapter, the mains available will be 220 volt. Then that will be converted to 9 volt or 12 volt or up to 18 volt it will accept by using adapter. So here this is one type of source of power. And another one is directly from USB as we are connecting for programming. That also you can use as the power supply. So without this connecting to the power jack, you can execute the program because that USB will have the plus 5 volt. And this one is for serial communication interfacing using UART. So you can, this also can be used. So provided the desktop should have that facility for connecting this serial communication port. So nowadays, desktop also will have only USB, and laptop will have also USB. That is the reason we are using the SPI interface and also the separate programmer that will convert from USB to this SPI. So easily we can use the USB based, and this is the power on and off, and this is a regulator to get 5 volt. It is a 7805 IC, and this capacitor used to filter the signal to make pure DC. So these are all related with the power, because if you get AC also to convert it to DC, and this 805 microcontroller required 5 volt DC supply that we can uh, give from this power jack or from this USB. From here also we can get the VCC. Okay, either one you can use. Then here crystal has been connected to generate the clock signals, and two capacitor for this along with crystal. These are the main parts of this board. Okay, here main is this 8051 based microcontroller. The particular is 889S52. It is from Atmel company. Now, yeah, same once again here the pin configuration of the 805 microcontroller. All the pins has been mentioned here. See, 40 pin is VCC and 28 is ground, and these two are connected to crystal, and these are for port 3 as well as other special functions for receiving, transmitting, interrupt, timer, counter, then write and read the signals for if you connect the external memory. Then here, whenever if you connect any external memory, also we need address and data bus. This bus can be used IO pin as well as address and data pins, and these pins can be used as address pins whenever if you use any external memory. And this is program store enable. If you use a ROM, you are going to use this either address latch enable for latching the address, and this is for either externally you're using any ROM or we are using your internal. Okay, and this is a reset pin. Pin number 9 is the reset pin. So these are all about the 8051 microcontroller pin. It is a 40 pin IC. It is a 40 pin IC. So here out of 40, 32 pins are IO pins. 32. This is port 0, 8 pins, port 1, 8 pins, port 2, 8 pins, and port 3, 8 pins. Total 8 ports are 32 pins are IO pins only. So remaining few pins, 2 pins will be for VCC ground, 2 pins for crystal. Okay, only 2 pins are there. So here important is the IO pins, because these IO pins are required to interface any IO device. So same, just to understand here another form here represented the pin diagram, so that it is consist of port 0, port 1, port 2, port 3, and Here pin 9 is reset, then the crystal is connected. Okay. Then pin number 31 is connected to VCC so that we can use the internal ROM. So here, this is a program to blink an LED using assembly level language. Here, let me explain this assembly level language. So ORG is the directive. It will give the direction to the assembler where to store the instructions. What is the starting address of the memory location? Here, after ORG, the number will be written. This is will be the starting address of the memory. The following instructions will be stored. Here it is 00. The starting address for storing this program will be 00. Set B, set bit. Here the port 0.0 is we are making as high 1. Is nothing but 5 volt will be connected to this pin. You can available. So this pin is connected to LED. So LED become on, and we are using some delay program. So that is the reason this delay will give very small amount of time. Time, that is the reason I used repeatedly. So I used here 10 times this delay. Then clear to send as 0 to make LED off. So clear P 0.0. You're sending 0 volt to the pin number 0.0. So 0.0. Then we wait some time. Then after that, jump back once again. Repeat. Is a on, off, on, off. It will be repeated with some delay. So here it will be hold on here only, jump back to. So whenever it is called a call delay, calling the subroutine, it will go to this delay program and load the value R2 hash 0FF. Means any immediate value to be stored into the register, then you have to use this hash symbol. So R2 will be stored as FF, then new R3 will be stored as FF. Here decrement R3, content of R3, if it is not 0, it will repeat. Then once it becomes 0, then decrement R2. So if it is not 0, then it will load once again this R3 and it will repeat. So here FF is nothing but 255. 255 into 255 times these instructions are going to execute. Then once it completes 255 into 255 times, then go back to the main program. We come to here. Once again, second a call delay, once again go like this. 10 times it will go and will come back to the main program. So this is about assembly level of this program. Similarly, for embedded C language program, here in embedded C, we have to include rig52.h. Means all the registers has been defined in this header file. That is the reason whenever we are going to use any ports, so we need to include this header file. Then S bit, it is a single bit SFR. So S bit port 0.0, this particular bit we are going to assign some name as LED. Then this Y delay is the prototype delay function declaration. Then wide main, the actual program will start execution from here, wide main. While one is the infinite loop. Then first we'll make this P 0.0 as 0. Then use some delay function. We are calling the delay function here. Then we'll make LED equal to 1. Then the LED will be on. Then delay, we have to call once again. Here the delay program, we are using ij as variables of type integer. So we have to declare before using this. So Y delay is the function name. And to start this delay program, so we are using this ij as variable that we are declared here as int j and int I. Then for I equal to 0, I less than 100, I plus plus. So it will repeats 100 times. Then inside this 100 into this 1000 times, inside 1000 to 100 times, it is going to repeat these two loops. So this is about the program, how we are going to write in embedded C. So further, if any assistance required, please feel free to contact. So now let us see how to implement, execute this program. Now I will stop this PPT. Then we'll see the live. Now share screen, share. Now here